Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a Big Bang.
The Big Bang model shows how the universe became what it is today. The universe and all the matter that is in it started out as an extremely small point. Then, over a short amount of time, it expanded rapidly. This is similar to an explosion when a bomb goes off or something similar to that. It starts out small and then gets really big, and it's very quick. That's why it's called the Big Bang, because it's similar. Over time, the universe has kept expanding. Scientists have found what they call dark matter, which is basically an anti-gravity. This is the reasoning behind why the universe keeps expanding and why it will continue to expand.
Georges Lemaitre was a Belgian Catholic priest and an astronomer, as well as a physics professor. He was the first academic to propose the idea of the Big Bang. His idea suggested that the universe began with the explosion of what he called the primeval atom. Lemaitre proposed that cosmic rays may in fact be the leftover artifacts of the initial explosion. Although Georges Lemaitre is the true founder of the Big Bang, Edwin Hubble is often the man who gets all the credit for the idea. In 1929, Edwin Hubble discovered that the universe is expanding at an enormous rate. By observing galaxies steadily moving apart from each other, he was able to infer that at one point everything was extremely close together. Hubble's discovery caused the popularity of the Big Bang to skyrocket. In large part because of this discovery, the Big Bang Theory is to this day considered the best model we have of the origin of our universe.
There has been a lot of scientific evidence found that supports the Big Bang Theory, but we are going to focus on these three. The first one is the Doppler effect. When a star is either moving away from or getting closer to us, we see that star's light differently. The spectrum of the light changes the color we receive here on Earth. The more red the light is, the faster it is moving away from us, while the more blue the light is, the faster it is moving towards us. When Hubble was studying galaxies, he realized that most of the galaxies he found were red-shifted, meaning they are moving away from us, especially the ones that were already very far away, which agrees with the main idea of the Big Bang Theory that the universe is expanding. The observed abundance of elements also agrees with the Big Bang Theory. The amount and abundances of elements we find in the universe also fall in line with this theory. At the very beginning of the creation of the universe, everything was so hot that protons, electrons, and neutrons could move freely without combining to form elements. When the universe began to cool and expand rather quickly, protons started combining into helium and hydrogen because these are the most basic and light elements. Other processes that came later form the other heavier elements. This explains why we have so much more hydrogen and helium in our universe than all the other elements. The Big Bang Theory also accurately predicted the distribution and formation of galaxies. This theory predicted that younger galaxies would appear further away and redshifted because the light we receive from them has traveled very far distances in space to get to us, meaning it is actually very old light that is just now reaching us. This prediction was found to be true. The findings also disprove the prediction made by the steady-state model that said that there should be an even distribution of old and young galaxies all around us, which is not what we observe.
Before the Big Bang was accepted as fact, there were other models competing for how the universe was created. One being the eternal static model, which was proposed by Albert Einstein. Einstein was a strong believer of a finite and eternal universe. To prove his theory, he revised his general relativity formula. This idea became widely accepted over the Big Bang by the majority of scientists. Another competitor of the Big Bang was the steady-state model, which had been suggested by Hoyle, Bondi, and Gould. It was a compromise between Einstein's eternal universe and the Big Bang's expanding one. Like the Big Bang, it proposed that the universe was expanding, but in the gaps between galaxies, new matter was constantly forming, causing the density to remain the same. Both theories eventually teetered out, leaving the Big Bang as the winning model.
Overall, the countless theorists, scientists, and physicists that worked on the Big Bang model of the universe helped create solutions to the questions formed by our observations of the world around us. Because of their hard work and dedication, the Big Bang model is considered the commanding theory in today's times and is constantly refining and adding to our understanding of the universe we live in.